Hi everyone, I'm Dr. Lisa Bagnall from We Teach Nursing. If you have any questions, don't forget to contact me through We Teach Nursing Facebook page. Today begins the series on dysrhythmia recognition and treatment. You will find 3 or 4 short videos on dysrhythmia recognition, and then there will be a separate narrated PowerPoint for dysrhythmia treatment. Today will be the longest of the series, and it's the basic understanding of the physiology of the heart all the way through normal sinus rhythm. Before we can talk about the different dysrhythmias, we need to understand how the electrical system of the heart normally functions. When the SA node receives an electrical signal, it depolarizes. And when it depolarizes, the electrical current moves through the internodal pathways to the AV node. When the AV node is depolarized, that signal then moves through the bundle of His, down through the right and left bundle branches, and then into the Purkinje fibers. This is a rhythmic cycle of depolarization and repolarization. And hopefully it is followed by mechanical function, or the pumping function of the heart. You need to understand a few bits of nomenclature before we really get into the meat and potatoes of this video. Now remember that the normal EKG tracings consist of waveform components that indicate electrical events during one particular heartbeat, or individual heartbeat. The P wave right here is the first deflection and is normally positive or upward. It indicates atrial depolarization. It should be rounded and upright, and it should begin and end at the isoelectric line, or the baseline. That is that here. The QRS complex follows the P wave, and it normally begins with a downward deflection, and then an upward, and then a downward. That's the QRS. However, please understand that sometimes you will only see an upright and downward deflection. It's all known as the QRS complex, and that is normal. That represents ventricular depolarization. The T wave is normally a modest upward waveform, and it follows the QRS complex. It represents ventricular repolarization. And I already hear a question, what about atrial repolarization? Where would you see that, Dr. Bagnall? Well, you would see it most likely in the QRS complex, but because that is a larger electrical impulse, it will be buried within that QRS complex, so you're not going to see atrial repolarization. Now sometimes you'll pick up a U wave, and it just indicates basically the recovery of the Purkinje fibers. We don't tend to look at that so much. So it's a P wave, QRS, and T. Atrial depolarization, ventricular depolarization, ventricular repolarization. And here you go. This is another picture that represents the P wave being the SA node and atrial depolarization. The QRS, again, that represents ventricular depolarization, and the T wave, which is recovery of the ventricles via repolarization. Now, once you have depolarization, the atria should contract and empty blood into the ventricles. When you get ventricular depolarization, what follows that should be ventricular contraction. And this is in the normal heart and in a normal state. Okay. In order to have depolarization and repolarization, this just shows action potential and the switching of electrolytes, primarily the sodium and potassium channels that exchange ions. That is essentially what causes depolarization, repolarization. And I'm not going to go really into that. If you need to go in depth, then by all means look at another YouTube video or your book or wherever you need to go. Waveforms, okay, we talked about this. Not only does the P wave begin and end at the isoelectric line, but all waveforms should begin and end at this baseline. When we look at the EKG paper, you'll notice that there's teeny weeny boxes, and then there are 5 teeny boxes that make one large box, and you'll notice that with the larger, darker lines. They represent time. And each small box here is 0.04 seconds. 5 of these, 5 times 0.04 is 0.2 seconds in time. When you look at the 6-second strip, that's going to equal 30 large boxes. And this is important because if a patient has a normal rhythm and you count the number of QRS complexes in 30 boxes or a 6-second strip and multiply that by 10, you will get the patient's heart rate. Let's take a look at an example for that. Okay, so here we have 30 large boxes. You'll see from one mark here to this mark here represents 3 seconds. From here to here is 6 seconds, or 30 boxes. So if I count the number of QRS complexes, 1, 2, 3, 4, and so forth, and I count that there are 9 in 6 seconds, 9 times 10 equals 90. And that is one way to tell heart rate. So let's take a look here. Count the number of QRS complexes, and honestly, for all intents and purposes, most dysrhythmia tests contain 6-second strips. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times 10 is what? Well, I hope you know that by now, right? 110. That's the heart rate. But there's another way to calculate heart rate, and that is by looking at the complexes and where they fall. And it's best to find one that falls close to or on top of a dark line, or the beginning of a large box, like it does here. And what you do is each box to each large box is basically 300. So if I had a complex here and I had a complex on the very next box, I would have a heart rate of 300, which would be almost impossible, right? But not impossible when you're talking about atrial rates, which we will get into later in this series. So you take the boxes, the number of boxes, and divide it 300 by the number of boxes. So for example, 1, 2, almost 3. That would be 300 divided by 3, or a heart rate of 100. And when I was learning EKG dysrhythmias and rhythm interpretation, I actually memorized this formula. And it's 300, 150, 100, 75, 60, 50, 40s, 30s. So if I have a complex here and I have a complex 3 boxes later and it marches out, I would have a heart rate of 100. Whenever you interpret EKGs, you have to use a formula. And this is important, and it must be consistent, because one rhythm can actually look like something else unless you actually take the time to use a specific formula each and every time to determine what criteria it actually fits in. First thing you want to look at is the rate normal, slow, or fast. And we all know that normal heart rate for the adult is 60 to 100 beats per minute. Is the rhythm regular or irregular? Do the QRS complexes fall at the same time, the same distance each and every time? Or do they not? Are there any P waves? If so, is there a P wave before every QRS complex? And if so, what is the PR interval? We're going to get into that in a moment. Is it regular and normal? Is the QRS narrow or wide? And what do we mean by that? A QRS width of less than 3 little boxes is considered narrow. Anything greater than that is considered wide. T waves, are they normal, and do they start and end at the baseline? Remember, everything theoretically should begin and end at that isoelectric line or the baseline. The QT interval should be also less than 0.50. Is it, or is it longer? We're going to talk about tachydysrhythmias, bradydysrhythmias, premature complexes, repetitive rhythm complexes, and so forth. Now, I want to talk to you about the different intervals and then what normal sinus rhythm looks like. We talked about, is the rate normal, slow, or fast? 1, 2, 3, 4, 5, 6, 7, 8 complexes in this 6-second strip means that the heart rate is normal. Is it regular or irregular? So you can either buy a set of calibers and keep them with you, or you can take a piece of paper, hold it below this rhythm strip, put a little mark here, and a little mark there, and a little mark here, and then march it down the strip. And if the lines fall in line with the QRS complexes, guess what? It's regular. Are there P waves? Yes, there are. Those are normal and round, and they precede the QRS complex. The PR interval, is that normal? Well, the PR interval is the beginning of the P wave to the beginning of the QRS complex. And the beginning of that P wave to the beginning of the QRS complex should equal 0.12 to 0.20 seconds, or 3 to 5 small boxes. Again, it's easiest if you can find a P wave or a QRS that starts or is in line with one of these large boxes. So let's take a look at this one. This one starts right after it. 1, 2, 3, 4. The beginning of this P wave to the beginning of this QRS complex equals 4 boxes. 4 times 0.04 seconds is 0.16. I just told you that normal PR interval was 3 to 5 boxes, or 0.12 to 0.20 seconds. Therefore, 0.16 is normal. The QRS complex, the beginning of that to the end of that, should be less than 3 boxes in width, or 0.12 seconds in width. Here it is 0.08 or thereabouts, and yes, that means it is narrow. Now, one of the most important intervals that is often overlooked by nurses is the QT interval, and it is extremely important because there are many drugs that affect this interval, and if it's too long, it can put the patient into a lethal dysrhythmia very quickly. The beginning of the Q wave, or the QRS complex, to the end of the T wave is known as the QT interval, and that should be less than 0.50 seconds. And that would equal less than about 12 to 13 boxes in length. Here, all the intervals are normal. The rate is normal, and therefore this is truly the definition of normal sinus rhythm. And this is going to end this particular video. Stay tuned for sinus rhythms and sinus dysrhythmias.